For you. Like I said, looking at the results, looked like you guys did a good job. Obviously, watched video. We'll check for understanding went well. And so here in our class, we're just going to do a couple of practice problems with this, one application with this, kind of see where you're at, and we'll just kind of move forward from there. So number 6 says d dx of 5 to the x. As I mentioned before, chapter 5 is a lot about learning skills again. And in this case, really, honestly, memorizing rules. I think in the video I show you a little bit where some of the rules come from, but we want you to get to a place where you can look at a question like number 6 and know right away that the derivative of 5 to the x is sin of 5 times 5 to the x. Can I show you what some really bad stuff that I've seen in the past? There's a temptation to do this. What is that person doing? They're trying to do a power rule with an exponential. It simply is not correct. And so we don't want to do something like that. We want to remember, of course, that the correct process involves natural log. So it's going to be natural log, as you guys said, natural log of 5 times 5 to the x. Okay.
Why would we use absolute value for this one?
Well, because positive 5 is positive. If you want to put absolute values on that, feel free. But don't feel the need to. Okay. And then, of course, number 7. Whoops, there we go. Number 7 is in a lot of ways just like number 6, except the exponent is not just a simplistic x. It's 9x. So the chain rule is going to show up here, right? The chain rule was present with the other one, but it was just times 1. And so with this one, it's going to show up a little more obviously. This is going to give us what? ln of 7 times 9. That last piece is from the chain rule. So there you go. All right, why don't you guys try number 8 if you haven't already looked at that. Hopefully just remembering from the video is what you need here to complete number 8. And we'll look at number 9 a little bit together here. So check out number 8. You guys recognize the language in number 9? Find the particular solution showing separation of variables. Well, that'll be involved for sure. So chapter 6 is all about this. Definitely a huge feature of chapter 6. So let's do this together. As it currently stands, do you see how the variables are not separated? Yeah. So let me ask you, what would need to be done to get the variables separated? Multiply the dx over to the other side. So it'd be dy is equal to 5 to the x dx. And once you have separated the variables, this gives us the opportunity to find the antiderivatives. So I'm going to attempt to do that by putting in the tall skinny s. The antiderivative of dy is just y. And what's the antiderivative of 5 to the x? Yep. And that, like you said, plus c. Very good. Okay, so at this point you found the antiderivative, the general solution. We want to try to use our initial condition to find the particular solution. And we know that y of 1 is 3. So that means y is 3 when x is 1. So it'd be 3 equals 1 over natural log of 5 times 5 to the first plus c. Well, c is not the most pleasant number. It's 3 minus 5 over ln of 5. That doesn't mean that it's wrong, just whatever it is. So then our final step here would be then to go back and write y equals 1 over natural log of 5 times 5 to the x plus 3 minus 5 over natural log of 5. We actually write out what the c actually is. Sure, we could do a little bit of simplifying there. There's really no need to do that in a case like this, so we could leave it alone. But that would be our particular solution. So is this a good connection? Do you see this goes back to the start of chapter 4, and it's also a little foreshadowing towards chapter 6 as well. So I'm right. We're done at 25, right?
Yeah.
Okay. Awesome. Have a good rest of your day. Good job with the video. I'll see you tomorrow.
So are